Right? This is the section view, and all these things are given, right? All these things are given. You just open it and then just try to even the dimensions. I'll come to this one later, right? With dimensions can also be added later. But anyway, you can give an attempt, right? No harm. Okay, let's see now. Now, when you take a drawing, you can see there are different drawings. Some are simple, some are very complicated, and sometimes you don't believe some of these things are manually drawn. Right? This is could be a product drawing. There are different what you call the categories of drawings. You have to identify that one. And this is a component drawing. Right? The component details are there. In addition to your lines, arcs, circles, and other geometries, you can see there are a lot of text over here. There are a lot of text over here. Why? Because you want to make sure that this is a unique thing, right? A unique thing. And then this is an assembly drawing, right? And of course, you can say even the component drawing, where the part list is there on the bottom right-hand corner. Projection is there, scale is there, date, drawn by, all these things has to be there. Once you go to the industry, you have to follow the standard of that particular organization. If it is not there, then you can develop one. Sectional views. When you give the section views, usually we don't give the hidden lines because this will become more ambiguous. Why we give sectional views? To eliminate the hidden lines. I'll show you one picture over there. And then you can say even the exploded views, right? Exploded view is the part list. Now, can you imagine that how you're going to produce these things on the manual drawing board manually when there were no computers, software at the very early days? People still did that one, right? People still did that one. So whatever the drawing is, remember, it should describe the exact shape and the size. And also it should convey a unique message. Remember, a single drawing cannot convey 2-3 different messages, 2-3 different parts. Means something is missing, or maybe it is completely wrong. It has to be a unique part, only one. Right? So hence it is required to follow a set of fixed rules and prepare. Right. So we need to follow the guidelines, the standards. This is what most people are not doing today. We cannot change, right? We cannot change. Just because I understand, just because you understand, just because few other people can understand, this is not the standard. So there are standards. So without doing, even if you create a sketch, a freehand sketch on a piece of paper, that you still need to follow these things, then only you practice those things. Right? Otherwise, what happens is there's a chance that it's going to misinterpret. Right? There's a standard and they are there. But I think I showed you this one day. If you think of the projection, why 2D drawings are all projections onto a piece of paper where the thickness cannot be used for any purpose. All 3D objects how do I communicate? Remember, before somebody else, so this is how they develop this engineering drawing and other languages like this. There are different things, but our interest is in orthographic projections, and then we go for the multi-view. And there again, we have first angle and the third angle projections. Everything else, at least you should have some idea, right? You should have some idea. First angle, but we don't use second and the fourth angle. If possible, someone can find out why are we not using second angle and the fourth angle. First angle and the third angle projections are being used. But in Sri Lanka, we use what? First angle projection. And also axonometric projection, we call isometric. You know, it's nothing, right? You can just click on the button and then you can say in addition to that one, we have dimetric and trimetric. We don't usually call this one in manual drawing world, it's only isometric. because of the differences in the dimension scales and other things, going to be difficult to produce these drawings. First angle projection. This is the standard. I think you have this thing, right? This is given with your handout. I don't know how many of you have that one. Right? This you and I can't violate. Look at this view A to view F. Right? Am I correct? Yes. Right? View. There is a definite location for all these views. I cannot change. I cannot change. So for suppose I have view D, I have view D, and then I don't have view C because maybe it is same as view D. Then I have view F instead of that one. Then it is wrong. Because that position is for left side view. If the left side is view is there, then you have the these positions aligned. All views horizontally aligned. Vertically, you can see aligned. And you can see a picture of the view on the bottom left-hand corner, the user and then the object and the projection plane is. You look from left-hand side, project onto the right-hand side. And the projection symbol is the one that we usually indicate. We don't write usually, right? We don't write. We just put this one. And even in that symbol, there are proportions. You cannot just draw on your own, right? There are standard sizes, proportions for this one. And similarly, the third angle projection. You can compare this one and that one once you get the note. Where if you see the plane has now come into the middle. So you observe from the left hand side and project to the same side. That is the third angle projection, right? Still you can stand there. And when you have the top view, in this particular case, top view is above. In the first angle projection, top view or the plan view is bottom, right? Two different orientation. Most of the software that we receive from USA, the default is set to third angle projection. Even from German, Australia, they all use third angle projection, right? Third angle projection. So you have to be very careful. Don't project according to the third angle projection and then manually move the views. It's also possible, right? Then you are making a mesh out of all these things, right? And then a particular drawing. Maybe this is also familiar to you, I don't know, right? With hidden lines. You see, with hidden lines and everything is over there, right? But let's say, this is hidden line. Okay, I use the same thing. But anyway, let's assume that all will be hidden lines. What will be the case? I actually remove the section line from the same view. Let's look at the other one. Which one is more clear? Go back to the previous one again and look at this one again. The reason why we use the sectioning to give a more understandable view of the inside of the object, And then here you can say a production drawing. Lot of here, in addition to the dimensions, even the dimensions, I can't find my familiar dimensions. Right? Now, sometimes the tolerances are given, sometimes the limits are given. Like for example, the diameter is given 44.60 and 44.45. Diameter maximum and the minimums are given. Remember, you can't write 44.60, 160, 0.60 and 0.600. Sometimes the software is set to give you 4 decimal places. That is again when you compare the imperial units, right? So you just change the units, but not the number of decimal places. So still it becomes 4 decimal places. It's a how many? A fraction of a micron, say 0.1 microns. If you say 1, 2, 0.2 microns. You need to understand on what particular machine that we can go up to that level. So in the production drawing, we have to give all the details. I will before I take the next one, right? It will not be on the next week. Once you have come to a certain level, then I will explain. Otherwise, it is useless. And these are the standards. Unfortunately, you can't have these standards. These are very expensive. Separate BSP, how to separate. You see, these are the guidelines that we need to follow. Look at on the right hand side what guidelines are available as per the ASME. Right? Some of the things are actually available to download, but not maybe not the updates. Sometimes you have even the updates. So this is 2009 and 2012. As far as I know that it is 2018 right now. Right? So a lot of details are given there. So I'm talking into one of these things. So you take the first one, it's only given the dimensions. And you take the second one, it has even the tolerances given, upper limit and the lower limit. Whereas on the picture on the right hand side, it's given with some tolerances. So let me explain what does it mean. Now this means the symbol, there's a symbol and then the value, and then we have the reference frame over here. Right? Only thing is the A is missing here. Now this says this particular surface. What is this particular surface? Perhaps this one. Right? It should be parallel, and then the limit is 0.05, 0.05. Right? With what? With reference surface A. I have given a different chart for this one. I will come to that one. Now again, the dimensions. I know that most of you are not following this thing. There are only two standards in the dimensions. One is the unidirectional system, other one is the line system. You cannot mix them up. Please remember that. You cannot mix them up. Right? Because in the vertical things, you can't put the dimensions, the line may be somewhere there. So you split the horizontal lines as well. In the aligned system, the dimension is always aligned with the feature. If it is at an angle, it will be aligned with that one. And then text will be above. If you want, you can even put them in the middle. That is aligned. You cannot mix them up, right? You cannot mix them up aligned with this one. And also, if you take something like this, for example, 11.7, you cannot put the dimension onto the right hand side. You cannot write this 22 below the dimension line. Sometimes when you do it manually, many students, even those who are working in the industry, they do the same mistake, right? They do the same mistake. So why do we need a production drawing? Because if we want to manufacture that one, we need all this information. A general drawing will not provide us all with all this information. We need to have all dimensions. In other words, in what you call the modeling terms, you call the fully defined, right? It has to be all the dimensions need to be given. And then production operations, whether it is milling, facing, drilling, whatever it is, need to be surface finish and identify the exact material, maybe the trade name, number of items, and then limits, fits, and tolerances. Right? Now, this is quite interesting because now you are producing your own parts, right? You are the one who is going to decide which dimension is to be put in the drawing. Earlier, you were just copying someone else's drawings, but this time, no. There's a special thing that you have to understand. So this is what we call the functional dimension and the non-functional dimensions. Left hand side, the functional, the assembly is given. The purpose of this bolt is to this one, maybe with a clearance or maybe without a clearance. If it is fully pulley, then there has to be a clearance. although this picture is not very, let's try to use this particular thing. So if you see the f as a functional dimension, what does it mean? The pulley width, so this f need to be more than the pulley width if the pulley needs to rotate freely. You give this dimension f, and then you define this dimension over here. You can derive that dimension, right? So this is going to disappear. So then you manufacture this one to the required tolerances. At that time, this one, some of the parts can be out. Why? Because you are not taking any measurements of this part. Non-functionals, you are not going to take any measurements. Look at this head portion. It's not that important. Head. Although there are standards, but whether it is plus or minus 0.1, 0.2 millimeters, it's no harm. Right? No harm. But whereas the other thing is very important. Other things are also very important. Right? Now here you can see at this particular thing, f is given here as a function, the depth of the thread. And also you can see there's a small undercut. Why is that? Because you can see the here. This part, that is this part of the bolt body, should come and stay tighten with the main body. Right? So if the thread is too long, then this will come and block here, but there won't be any connection here. So that means this F need to be shorter than the depth of the hole. So this is how you identify, in a way, what you call the dimension scheme. I remember I repeatedly tell you, do not violate the dimension scheme. This is the reason, right? So this is the reason. So let's try all things, and then you will be able to, you know, try to apply. Definitely you're going to get many questions after that. Your title cage should include, you see, the materials, the treatment, means whether it is to be finished with the grinding or maybe polishing or maybe apply some paint or whatever it is. And then the tolerances, where you have 2 decimal places, 3 decimal places. These are the, I have not given it specifically. And then drawn by, check by, all these things has to be included, right? All these things need to be included. Right? This is what I want you to see this one. So this is in the note as well. So prepare something similar to that. I think with that, I will stop the lecture today. Please practice all these things. Right now, you should be ready. Right? And also do the corrections of or apply the comments that what we have given during the evaluation of your models. Right? Now you can see your models are still very simple models, right? Maybe you have spent a lot of time on these things. That also you have to understand, why did I spend such a lot of time in creating such a simple part? If you have some interest in creating those things, especially learning, not just copying, then within few weeks you should be able to capture the art of modeling these things in any software, and then you will have to continue. Then you find out even shortcuts like templates. Today I explained. So you don't want to worry about drawings. Now if the parts are ready, then you just open a template and then insert the views and then keep them. And then later when you apply the dimensions, then you can apply it. Right? So even these tolerances, I will come to this one a bit later. Right? And also with animations. Not today, but animations are also not that difficult for simple animations. I will take probably one day for your sessions. And if you have any questions, right, you can bring all of them to that particular day. Right. Any questions? There are only 52 students, probably including some staff members. I don't know what will happen to the rest of the class. This is usual. 52 is actually a good number, right, compared to the previous years when we do it physical classes. I mean, the last few weeks there was only maybe less than 10 students, right? And those students perform well, right? Those perform well. I can even show their models to you to see the difference. So to see the difference, that means it is possible. It's not something it is impossible, right? Don't think that is difficult and everything. What industry is looking for is maybe 10 times, even 20 times more difficult than these things, right? So you need to get ready for these things as well. This is just a tool. You are using only a tool, nothing else, right? But your background knowledge on how to use the tools and apply these different conditions, that is what you have to learn, right? So I will stop for today, and then we'll continue maybe after 1 week or maybe after 2 weeks, but definitely before your final submission, right? So make sure that you have your questions and practice everything, right? After that, there won't be any explanations and everything, right? So you can easily earn marks if you just follow these things. Okay, I will stop here today. Thanks for waiting and listening.